is we are given a graph and we want to find the first 6 terms of the sequence. Then we're going to ask question number 2. We're going to describe the sequence. Then we're going to find this funky S with the little 7. Then we're going to find S with parentheses 10. And then we're going to describe how the graph changes, okay? If you watch the video and you're pretty good with the video, some of this you were like, I know how to do this already. We're good to go, okay? So before I start, the first thing I want to mention is if we look at problem 3, okay, and problem 4, they use the letter S in both problem 3 and 4. What this letter S is doing is telling us that our function, okay, the name of our function is S. So as a reminder, I want to remind you that functions are basically the graphs. Okay, a function is a graph. We could turn functions into graph. A function is an input-output table. A function is an equation. Okay, a function is actually also a sequence. So I'm going to write that here at the bottom. Functions can be represented many different ways. They can be shown as a graph, a table, the input-output table. You can, you don't have to. I'm going to do the work for you. But if you want to put it on your paper, you can, just so you can have reference. And then we could also have an equation. And then lastly, what we're talking about is a function can be a sequence. So it's very important that you understand that the name of my sequence is the letter S. So don't freak out like, what the heck does this S mean? It just means this is the name of my function. And the function that we have right now is in graph form. Once you have it in graph form, we could turn it into any one of these. That's kind of what we practiced the last couple of weeks. If I gave you a table, you were able to turn a table into a graph. If I gave you points, you're able to turn points into a table. And then we started writing rules. And we called those rules equations. Okay, so the rule was just an equation, another way for an equation. So long story short is, this is our function and its name is S. That's what this is telling us here. Okay? So number 1, we're going to write the first 6 terms of our sequence. Where do we get the sequence from? From our function. So the first thing I want to do is, in order to write a sequence, we need to basically know our table. In order to get the table, we're going to get the table from these points. So I want to write down the ordered pair for these points. So it's going to be 1, 3 for that point. And careful when you write these down. If you notice, the y-axis is going by 2, so it's 2, 4, 6, 8, 10, 12. I was doing this earlier and I made that mistake and I thought it was going by 1s and it messed everything up. Okay, so that's 1, 3. This is going to be 2, 6. And this is going to be 3, 12. And this will be 4, 24. Okay? So the last couple of weeks, we were able to take these points, and then make an input-output table. All right? So I'm going to make an input-output table. But this is not actually the answer for number 1. So the input-output table looks something like this. Okay, this is our X, this is our Y. So my input for the first was 1, and now I have 3 with that. So 1, 3. The next one is 2, 6. And then we have 3, 12. And lastly, we have 424. Okay, so again, this is not the answer to number one, but I'm showing you how we get it. And I'm trying to connect it to what we've been doing the last couple of weeks. So if you look, this is our input, output. What a sequence is, in order for a function to have a sequence, all we're really talking about is the output. So if I want to write the sequence to this function, I am essentially doing this. From my input-output table, I really don't need my input at this point. All I need is my output. And now we have the first four terms of the sequence. Okay, so again, if you look, we got our points from our input output from our points. But when we talk about sequence, what we're really just looking at is the output. Okay? And this pretty much is not any different than what you were doing the last couple of weeks. But instead of input-output table, we essentially just want the output. So in the notes from the video, we know that this guy, we call this guy the first term. So we'll put that in black. And our sequence is S, right? Our function name is S. So we have S1, okay? That means in our function, we want the first term, so the first guy. Then we have the second guy in our function, third guy, and fourth guy. This is called subscript notation. This is how we use subscript notation. Okay? That's one way to do it. There is a second way to do notation. I'll put that in the bottom in purple. Instead of calling this S little 1, right, we can call it in function notation, which we would go S parentheses 1. This guy would be called S parentheses 2, S parentheses 3, and S parentheses 4. This is function notation. But they mean exactly the same thing. And this is what they mean. It means we're looking at the function S. So here's my function S in graph form. And I want the first part of the sequence, the first number in my sequence. And that is basically my first output. So my first output is 3. S3 here means I want the third output. My third output is 12. Okay? That's how this subscript works. It means the same thing here. When we use function notation, instead of using small numbers at the bottom, we're just using numbers in parentheses that mean the same thing. So it's, I want the first output of function S, which still would be 3. Okay, hopefully that's not too confusing. It's just two different ways of saying the same thing. One subscript notation, one's function notation. So for problem number 1, we're actually going to answer this. Write the first 6 terms of the sequence. So we got first, second, third, we got the fourth. Now we need the fifth. To write the fifth term, the fifth guy in our pattern, we have to figure out the pattern. How am I going from one number to the next? And to figure that out, you essentially just have to ask yourself, am I adding, subtracting, multiplying, or dividing something by this guy to get to the next term? Okay? Then and what am I adding, subtracting to get to this guy? What am I adding, subtracting, multiplying, dividing to get to that guy? So if you look, you're trying to figure out the pattern of our output. And if you do this correctly, in order to go from 3 to 6, I'm just going to multiply by 2. In order to go from 6 to 12, I should be able to do the same thing, multiply by 2. 12 to 24, multiplying by 2. So to get to my next term, I'm going to multiply 24 by 2, and that gives me 48. So this is my 5th term, but we want my 6th term. So to find the next term, I'm going to multiply by 2. And that gives me 96. So if you look, we have 1, 2, 3, 4, 5, 6. We have found the first 6 terms of our sequence. And we are done with number 1. Guys, I know it's a lot of information, but if you watch that video, it just kind of explains it a little deeper, okay? With some more examples. So hopefully this is not too bad. It's pretty much what we've been doing the last couple of weeks. All right, number 2. We want to describe how you go from one term of the sequence to the next. Well, we kind of figured that out already. How do I go from this guy to the next? I'm multiplying by 2. So I'm just going to write that in. By multiplying by 2. Okay? This question, number 2, is going to play a big role when we start going into more and more sequences. Okay? This is huge. Some of it's not straight up like, oh, it's just multiplying by 2. This actually gives you a lot of information, as you will see later. Okay, so it's important that we understand how I go to the next part of the sequence. All right, so now I want to find S7. So what that is saying is, in my function, I want the 7th term. Or in other words, the 7th number on the list. Okay? So if you look back to number 1, we have S1, S2, S3, S4, S5, S6. And how would I find S7? So let me rewrite the sequence here. So it's 3, 6, 12, 24. 48, 96. Okay, so this is S5, S6, and we want to know S7. So to do that, we just use what we answered in part 2. We're just going to get the next guy, we're going to multiply by 2. So again, if you're not cool with multiplying these big numbers, get your calculator out. Okay, and if you do this correctly, S7 should be 192. Okay, so the way you write that is S subscript 7, subscript means small little number underneath, equals 192. So this would be your answer for number 3. Okay, number 4, very similar to what we did in the problem number 3. So now we just want the 10th term. So again, this states in my function what is the 10th number or term. Okay, so doing that pattern again, we got 3, 6, 12, 24, 48, 96, 192. Hold on, we gotta let some people in. Okay, so can you figure out the 10th term there? Again, if you're struggling, use your calculator. So 192 times 2, 384, and then 384 times 2, 768, and then 768 times 2, 1536. So if you look at this, is that the 10th term? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer to this is, in function notation, S10 is 1536. Okay. All right, number 5. There's a vocabulary word I want you to start using when you have to describe the changes in a graph, okay? So let me put that vocabulary word down. We want to start using rate of change. And rate of change, what this simply means is this. Looking at your graph, you really can see rate of change in a graph, not necessarily in a table or an equation. The rate of change is when you move from left to right on your graph. So if I follow these dots from left to right, okay, are they going up? Is my graph going up or is my graph going down? Okay, so the rate of change is, you have two options. If it's going up, we call that an increase or increasing. If it's going down, we call that decreasing. So in this case, my rate of change from left to right, always from left to right, is my dots are going up, which means my rate of change, so this is how I would describe it, rate of change is increasing. Okay? But we're not done there. We got to look at one more thing. If you connect these dots, which I'm going to do for you now, hold on, give me a second, some more people are coming in. If I connect these dots as I have now, is my increase constant? So what does that mean? Is if it's constant, it should look like a straight line. It should be going up like a straight line. Okay? So when your increase is constant, you want to think that my dots are making a straight line. If you look at our particular example, I do not have a straight line. I have a curve. Okay? So I would put a rate of change as increasing, but not constant. Because I have a curve. Okay? All right, so again, we'll get comfortable with describing this, because that's what Im3 is about, is describing graphs and functions and sequences and all that good stuff. What I want to summarize is this. Understand that a function can come in many different ways, many different versions, but they're all still a function. And when you have a function, you can turn these different versions into each other. Tables can turn to graphs, equations can turn to a table, a sequence can turn back into a graph, okay? The other thing I want to mention is when we have a sequence, we're really just talking about the output part of our function. The input-output, we're looking at the output part, okay? And lastly, this should be reviewed, but I'm still going to go over it because it's part of the next set of problems. If you look at these points, we are used to calling these points X and Y, okay? But when we're dealing with function, because remember, this is function S, we no longer call them X and Y. We call them input and output. And what I mean by that is this. Our input can be any variable. For example, what if I call my input the variable N instead of X? Okay? That means my output is not N, but my output would be the function, in this case, S, when I plug in N. Okay? So it still means X and Y, but if I change the variable as N, I'm plugging in this number, N, into what function? I'm plugging it into the function S, and my output is 6 in this case. This still means input, output. Okay? This still means X, this still means Y. But sometimes when we're dealing with function, you will see ordered pairs labeled as this. And you're going to see it in problem 9 in the next screen. All right. So I'm going to switch over to the next screen. All right. Number 6, describe how you go from one term of the sequence to the next. So let me write down the sequence real quick. All right. And what you should have done here is notice that to go from one term to the next, you are going to be adding 6. So how do we do it? We add 6. Okay. Number 7, we're going to find K12. So it means we need to find the 12th term. So I got to add 6 until I get to the 12th term. So let's do that. Again, very simple with the calculator. So I'm going to add 6 to 19. That's 25. 31, we're just adding 6, 37, 43, 49, let's continue it down here, 55, 61, 67, 73. I'm just going to keep going. 79, 85, and we'll stop at 91 for now. So we want the 12th one. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So K12 is this guy. Okay. All right. If that's K12, we need K sub 15 or the 15th. So if that's 12, 13th, 14th, 15th. That's 85. All right. So now we're going to do the graph. Okay, so I want to real quick remember this is your sequence here. And to do the graph, we want to turn it into, think about it as a table. And based on what this says, as I mentioned earlier, your input, we're going to call it variable n. So this is variable n. And my output is k parentheses n, because we're doing function notation. All right. So n in this case stands for the term number. So the first term, this would be my first term, second term, third term, fourth term. And now because we have the input, output, I could put it in ordered pair form. So my first ordered pair is 1, 1. So 1, 1. My second ordered pair is 2, 7. Three, 13, and the last one is going to be 4, 19. All right, I'm gonna do a little graph here. We'll go by 2, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 2, 4, 6. And here we'll go by ones. 1, 2, 3, 4, 5, 6. All right, so let's plot these. 1, 1 is right here. Let's put them in red. And then we're going to have 2, 7. 2, 7 would be between 6 and 8. 3, 13. 3, 13. 8, 10, 12. Right around here. And then 4, 19. Here. Okay, so we have our graph. Yours should look very similar to that. And then last but not least, describe how the changes from one term to the next on the graph. So remember, we want to use rate of change as our answer. So we have to describe the rate of change. So the rate of change is it going up or down on our graph? It's going up. So that is increasing. Does it look like a line? So can I connect these as a line? Is it going up constantly? So if you look at this, because we're adding, a big hint is when you have to add to get to the next term, it's usually going to be a constant rate of change. We're constantly adding something. So increasing, and then we would use the word constantly or constant. Okay, and that's 6 through 10. Make sure you add this to your practice problems. All right. If you have any questions, let me know. I'm going to stay on till the end of the period. I'm going to give you the access code now. Make sure you check in. If you are new or anything like that and you still don't know how to do the check-in, stay on and we'll go from there. So today your check-in code is HAND. H-A-N-D. Once you check in, and if you have no questions, get the calendar work done, you are dismissed. See you guys. See ya.
Bye.
Bye. Have a good one. Bye.
So we don't have to get a password for the attendance?
What's that?
We don't have to get a password for the attendance?
Yeah, I gave it to you. It's hand.
Oh, okay. Sorry.
Yep.